Okay, so like I was saying, Blessing wants to join. Let me admit her. Okay, Blessing, you're welcome. Now, we are basically going to be looking at three things under these two main types of differential equations. But now in second order, we are going to look at four things, but these three basic things first. So first, we are going to look at the general form of a second order differential equation. Then we are going to see how to solve a second order differential equation and how to use the initial conditions in solving a second order differential equation. Okay, so this is the general form of a second order differential equation. It is of the form a d squared y by dx squared plus b dy dx plus cy equal to f of x. So this is the general form of a second order differential equation. This a, b, and c are all constants. This f of x could be 0 or could be any other function. So if the f of x is 0, then we call that differential equation a homogeneous second order. But most of the times you'll never be given a differential equation where f of x is 0. So this is a general form of a second order differential equation. But now there are also other forms where we don't have constants here. But to solve those other forms, we'll need to use substitutions, which the examiner is always going to give to you. So in this first part, we are going to focus on how to solve these second order differential equations of this form. Okay, so this is a general form of this differential equation. If possible, I think you guys can be taking down the notes here. Now that's the general form. Now let us see the steps to solve the second order differential equation. Okay, now to solve a second order differential equation, the very first thing to do is to find the auxiliary equation. Now the auxiliary equation in this case is going to be a quadratic equation, and this is how it's going to be. My a is going to stay, and I'll just replace this second derivative with another parameter squared. Maybe I can say maybe m squared plus b times plus bm plus c equal to 0. So this is the auxiliary equation of, forget about this f of x for now. The auxiliary equation is a quadratic equation where if I use the parameter m to be my variable, then the quadratic equation is going to be am squared plus bm plus c equal to 0. For example, let's just take an example of a second order differential equation and bring out the auxiliary equation. So for example, if I give you maybe d squared y by dx squared plus 3 dy by dx plus 4y equal to 5, for example, the auxiliary equation will be given by I have left with my computer because of connection issue. I don't know, can we see the presentation again? Okay, so let's just proceed from where we ended. Alright, so in this case the auxiliary equation, okay, is going to be, how is it going to be? It's going to be, if I use m, I'm going to have m squared plus 3m plus 5 equal to 0. Sorry, plus 4 equal to 0. So that is my auxiliary equation in this case. Now let me give another example. If I have maybe 2d squared y by dx squared, 2d squared y by dx squared plus 4 dy by dx plus 3 equal to e to the power x, then my auxiliary equation will be 2m squared plus 4m plus 3 equal to 0. Sorry, it's supposed to be 3y that is here.
Where is the comb that was here this one? What thing? Will you pass and finish this pawpaw? Pass and eat the pawpaw very fast. Eh? Yes, come and eat the pawpaw.
Okay, so auxiliary, anyways. So that's our auxiliary equation. Now when you have the auxiliary equation, we have to solve the auxiliary equation. So the second thing is solve the auxiliary equation. Now to solve the auxiliary equation, yes.
Peter, I don't understand why we're letting to be m. Is it y that we're letting to be m, or is it y dx?
The thing is, master, for me to really sit and start explaining how that auxiliary equation came about is going to be long. So that's why I'm just telling you that in the exam hall, you are not supposed to be proving the auxiliary equation. You're just supposed to state the auxiliary equation, and to state it, all you have to do is replace the squared y by dx squared by a parameter squared, replace dy by dx by that parameter, and replace the constant with replace y itself by the parameter to the power 0, and the parameter to the power 0 will just be 1, and you get the auxiliary equation directly. So that's why in this case the constant here is 1. That's why I'm just replacing the squared y by dx squared with m squared. I'm replacing dy by dx with m to the power 1, and I'm replacing y with m to the power 0. Then I'm multiplying it by the coefficients of the squared y by dx squared, dy by dx, and the y itself. I don't know if it's okay now.
Yes, okay.
Okay, so that is it. So like in this second one, like I said, when you're getting your auxiliary equation, we don't care about e to the x. It's not our problem. Our auxiliary equation is always a quadratic of that form. Okay, now the second thing is we have to solve the auxiliary equation. Now if we solve the auxiliary equation, we are going to have 3 cases because we have a quadratic. So if b squared minus 4ac, if b squared minus 4ac is greater than 0, that is, there are real and distinct roots. We can call the roots maybe m1 and m2. Now then we are going to have what we call a complementary function, and the complementary function is given by a e to the power the first root times x plus b e to the power the second root times x. It is a formula that you have to know. So whenever b squared minus 4ac is greater than 0, that is, you have real and distinct roots, after solving the auxiliary equation, this is going to be your complementary function. That is how you start solving your differential equation. because normally the general solution of a differential equation is a sum of this complementary function and what we call a particular integral. So the first thing to do is we have to find the complementary function. And to find the complementary function, we must solve the auxiliary equation. So let's just take this our first example here, where we have this differential equation. So if I solve my auxiliary equation, here, you see I'm going to have, you see that if we do for the discriminant, it's going to be 3 squared minus 4 times 4. No, this one is bad. Let me not start with this type of case. Let me put 4 here and let me put 3 here. So I'm going to have 4 here and 3 here. Now the discriminant is 4 squared, 16. 16 minus 12 is 4, so it is positive. So I'm normally going to have real and distinct roots. So let's just solve for the values of m. So if we solve this, we can just factorize into m plus 1 times m plus 3, and we are going to have two values of m. We are going to have m equal to -1 and m equal to -3. Now the complementary function is just deduced and is going to be a e to the power the first root -1x. I'll just write it as negative x, then plus b e to the power -3x. Then I'll specify, very important, that a and b are real numbers. So I'll specify that a and b are real numbers. So basically that is it. Even if you start with a e to the -3x, no problem. If you have a e to the -3x, you're not going to have a problem. And then write b e to the -1x, you're not going to have a problem. So that is it. Now the second case is when we have if our b squared minus 4ac is now equal to 0, that is, there are real and equal roots. Let's just say that the root is just m, maybe just m1, we just have one root. Then the complementary function in that case is equal to, this is a form, a plus bx times e to the power m1 times x. So let me take a case where maybe I have a differential equation. Let me say the squared y by the x squared, plus 4 dy by dx plus 4y equal to 5 sine x, for example. Now the auxiliary equation in this case, is just given by m squared plus 4m plus 4 equal to 0. Now if we find the discriminant, we are going to have 4 squared minus 4 times 4. That's 4 squared minus 4 squared, which is 0. Therefore we just have to solve for the value of m. Now realize that the left hand side is just m plus 2 all squared equal to 0. So we are going to have just one value of m equal to -2. So the complementary function is going to be a plus bx times e raised to the power -2x, because that is our root. And then for the last case is if b squared minus 4ac is less than 0. If b squared minus 4ac is less than 0, that is, there are complex roots. Now if I will just leave this part here, because as Mr. Jamio said, a topic that you have not done will not be complicated, and in these complex roots you need to know complex numbers. But let me just give you the form in case anything happens, but I will not look at the examples on it. But when I'll see the equations, then I'll see if complex root is coming, then I'll tell you guys. So in this case, let's just say that the roots are of the form m equal to m1 plus I plus or minus im2. Yes, I'm just writing it for writing sake. So I'm going to have e to the power m1x times a cos m2 x plus b sine m2x. That's it. And then in trigonometry, we can always convert this one to be in the form r cos something plus beta cos r cos into something, or r sine into something. So that's just it. But for now, let's just forget about this complex roots. Let's focus on the first two cases. So that's always the first thing to do. First of all, we solve the auxiliary equation. From there, we now deduce the complementary function. Now, the third thing to do is now to find a particular integral. So number 3 is determine. Yes, Grace, you're raising your hand. Do you have a question?
Okay. Good night, everyone. Are you getting me?
Yes, I'm getting.
Please, sir. Is solving the C going to help us to understand complex numbers? Because complex numbers is coming.
Solving the C will not help you to understand complex numbers, but instead you need to understand complex numbers to be able to solve the C. You see,
Okay.
so when you send me the exam, I will see the nature of the complex numbers there. Then we'll have a brief class on complex numbers.
Okay, sir.
Okay, now the third thing is determine the particular integral. We always call it YP. Okay, now since we began, you realize that we have not been touching f of x. So this is now when f of x comes into the picture, when we want to determine the particular integral. So you just have to note that the particular integral always resembles f of x. So what we are trying to say is that, let me just give you a list of when your f of x is something and how to write your particular integral. So this is the differential equation we are talking about. Okay, so I'm going to write different values of f of x and how your particular integral is going to look like. So if your f of x is a constant, let us say it is just a constant. No, let me not put a, let me put lambda. So if your f of x is a constant, okay, then you should also know that your yp is also going to be a constant. We can call it beta, not the same constant. Now if your f of x is linear, let us say lambda x plus mu, that is linear, then your yp is also going to be linear. I can say maybe beta x plus alpha. So it's also linear. So if it is quadratic, it's also going to be quadratic. So let me forget about polynomials. Now if it is exponential, let us say that it is maybe in the form lambda e raised to the power x, lambda e to the power x, then this man is also going to be in that exact form. Maybe it's now going to be in the form beta e to the power x, which means that if here is 2x, you're also going to respect 2x. Okay, if here was lambda x e to the, if it was lambda x e to the 2x, then let me go to the next stage. If now this one is maybe lambda x e to the power 2x, you see that there is a combination of what? There is a combination of a linear factor and the exponential factor. Okay, so here we are going to have linear factor is of the form what? Beta x plus alpha, and then the exponential factor will just put e to the power 2x. So they are just in exactly the same form, once you identify the form on the left hand side, it should be the exact form on the right hand side. Now imagine that you have something like maybe lambda e to the power x maybe plus 2. Yes, maybe lambda e to the power x plus, no, let me not say plus 2. Lambda e to the power x plus alpha.
What is this?
Now your yp is going to be in the exact form, so you are going to copy this part. This part is beta e to the power x. This part is beta e to the power x, and then the constant term is also in terms of a constant. You can call it maybe, I don't know, maybe c. So don't be scared, pa laughing. Don't be scared. You just have to know the exact form of the exact form of the right hand side. Then you're going to now let your yp to be that form. So now there are some things under this yp that you have to know. The first thing is that yp is a solution to the differential equation. In essence, what we mean is that if you come to this differential equation, this y here is a solution. That is why a times the squared y by the x squared plus b times the y dx plus cy is equal to f of x. So if yp is a solution to the differential equation, then it means that a times the squared yp by the x squared plus b times the yp on dx plus c times yp is equal to f of x. Now this one just means that you differentiate yp 2 times and replace here. This one means you differentiate it once and replace. This one means you just replace it, then you equate to f of x. Okay, so the last thing now is what we call the general solution. General solution. After this, I'll just take 2 examples and we solve in the 2 different cases. Now general solution. So the general solution is yg. It is just equal to the sum of the complementary function and a particular integral. So that will be your general solution. So you need to take your complementary function and you add it to your particular integral, then you get your general solution. So that's basically the history about second order differential equations. So let's take some examples and solve. Okay, so let's consider the differential equation the squared y by the x squared somebody has sent a message. Let me try to read. Please, here the particular integral is not needed. Eunice, where exactly is a particular integral not needed? Yp is a particular integral. We need to find it. Let's just solve an example and you see how it is always gotten. Because the first thing to do is we must let it to be something. Then we now find the values of lambda, the values of the constants that we have. Oh, I've also forgotten one form. Let me put another form again. If it is in the form of sine x, maybe your f of x is in the form of sine x or cos x, or maybe you have a combination of sine x and cos x. Your yp is the same for all those forms, and your yp is a cos x plus b sine x. Yes, I forgot that form. Let us have a tutorial question. So imagine you have a differential equation, the squared y by the x squared plus maybe 3 dy by dx plus 2y equal to 5e raised to the power x, and you are asked to find the complementary function, then find the particular integral. Sometimes they actually give you the particular integral, but in some cases they don't give you. Find the particular integral, hence find general solution. Okay, so to find a complementary function, we must start by solving the auxiliary equation. And our auxiliary equation in this case is going to be m squared plus 3m plus 2 equal to 0. Now, we don't even need to find a discriminant, or we can still find it, but most importantly, we need to find the values of m. So you can either use your quadratic formula or factorization. So we can factorize into m plus 1 times m plus 2 equal to 0. And from there, we have two values of m equal to -1 as well as -2. So the roots are real and distinct. So real and distinct roots.
Please, everyone, is it normal that I'm hearing nothing?
Oh, you're hearing nothing, Jesus Christ.
Yes, I think so. It's like copying
Yes,
his presentation.
I just realized that my mic was off.
Hmm. Okay, sir.
I don't know where we ended, even where you stop getting what I was saying.
At that complex number phase.
And nobody said.
Right at a complex number.
Hmm.
Yes,
Hmm.
I thought
Wait,
you were like typing it.
Yes, sir. When
oh,
you started typing this table.
when I started typing this table,
Yes, sir.
Jesus
Yes,
Christ. Okay, let me just explain. Please, in situations like that, just try to indicate, because when I'm presenting, I don't see the presentation. I'm actually seeing what I'm writing. So I don't know what is happening there. Okay, so I was saying that, how do we determine yp? Yp is a particular integral, and to determine it, we must look at our f of x. From the beginning, we're not concerned with f of x. So when determining yp, we now have to take into consideration what f of x is. Now, these are the various forms of that f of x can take, and these are the various yp's that we can have. So if your f of x is a constant, your yp must also be a constant, not the same constant, a different constant. You will need to find that constant, and I'll show you how to find it. If your f of x is linear, your yp must also take the same form, a linear form. If your f of x is in a form maybe lambda e to the 2x or lambda e to the x, let me say, or in fact any of these forms, or lambda e to the x, then your yp must also take the same form. It will be beta e to the x, a different constant e to the x, or a different constant e to the a different constant e to the 2x, or a different constant e to the x, and you need to find that constant. Now, if maybe your yp is of the form lambda x e to the x, if your f of x is in the form lambda x e to the 2x, then your yp, you see that this first portion of this, we have a combination of linear and exponential. So you are going to have the same combination of linear and exponential. Now, if you have a combination of exponential and a constant, you also have a combination of exponential and a constant. If you have sine x, or you have cos x, or you have a combination of sine x and cos x, your yp will be of the same form. It's just going to be a cos x plus b sine x. So whether your f of x is just sine x, or it is just cos x, or it is sine x plus cos x, your yp must be of the form a cos x plus b sine x. So that's basically what the table is all about. So in different situations, you need to let your yp to be different functions, and then you find the unknowns there. Now, yp, can you stop noise there? Yp is a solution to the differential equation. That means that if you have this differential equation, normally y is a solution to the differential equation. That is why we have a times the second derivative plus b times the first derivative plus c times the function itself equal to f of x. So if yp is a solution, it means that a times the second derivative of yp plus b times its first derivative plus c times the yp itself must give us f of x. this is what you are going to use to find the various constants in your YP. That's basically what you're going to use to find those constants. So lastly is what we call the general solution, and in the general solution we are summing the complementary function and a particular integral. So when we sum the complementary function and a particular integral, we have our general solution. That is actually where we are riding to, because at the end of the day, doing all of these things previously is to arrive at the general solution, which is the sum of a complementary function and a particular integral. So this was the tutorial that I just gave, where we have this differential equation. We are asked to find the complementary function, the particular integral, and then we find the general solution. So to find the complementary function, like I explained, we must first of all have our auxiliary equation. Now, either we look for the discriminant to know the type of complementary function we are going to have, or we just go ahead to find the values of m. Since it's quadratic, we use any method of our choice. So if we try to find the values of m, we see that we can easily factorize, and when we factorize, we are going to have this, and m is going to give us two values, -1 and -2. So we can conclude that they are real and distinct roots, and when they are real and distinct roots, our complementary function is equal to a e to the power the first root times x plus b e to the power -2x, and you must precise that a and b are constants. It's a must. If you don't do that, you will lose an answer mark. So this is your y, your complementary function for this question. Now, how do we find a particular integral? Now the thing is that this particular integral does not just depend on f of x, it also depends on the complementary function. In the second example, I'll try to explain that part. Yes. So in this case, our particular integral, like we said, it takes the form of the right hand side. The right hand side is a constant e to the x. So I'm going to let my particular integral to be equal to a constant, maybe lambda e to the power x, because that's the exact form on my right hand side. Then I will differentiate it 2 times, and then I will replace back into the differential equation. So when I do the first derivative, I'll just call it yp prime. Let me just say, when I do the first derivative, I'm going to have, since I'm differentiating with respect to x, it does not change. I'll have the same lambda e to the power x. And when I do the second derivative of yp with respect to x, I'll still have the same thing. That is lambda e to the power x. Now, since yp solves the differential equation, we are going to carry this second derivative and replace here. We carry the first derivative and replace. Then we replace the yp itself and equate to this and find the value of lambda. Then we now deduce what yp is going to be. So then we must write, since yp solves the differential equation, then we have that we have to replace the second derivative here, which is just this man, lambda e to the power x, plus 3 times the first derivative, which is still lambda e to the power x, then plus 2 times the yp itself, which is still lambda e to the power x. Then we now equate it to 5e raised to the power x. Now, from here we can just add like terms. Lambda plus 3 lambda is 4 lambda, plus 2 lambda plus 2 lambda is 6 lambda. So at the end of the day, no, I don't want to have constants. Let me just put 6 here. So I'm going to equate it to 6 instead. So at the end of the day, 6 lambda e to the x is equal to 6e to the x. And with that, we can just divide all through by e to the x, and we have lambda is equal to 1. So if lambda is equal to 1, in conclusion, we can basically say that our yp is equal to e to the power x, because our yp was normally lambda e to the power x. Yes, our yp was lambda e to the power x, but since lambda is 1, then this is the value, this is the function yp. And finally, the general solution, we'll just call it y. No need to be calling it yg. So y is equal to complementary function plus particular integral. So complementary function is this. So our complementary function is this. That's complementary function. Then particular integral is this. And we must specify that a and b are all real numbers. So doing that, we have solved the second order differential equation given to us. Okay, now let me take a situation. First of all, I don't know if it is okay. Any worry? Is there any question? Can we proceed?
I think we can proceed.
I'm confused. I am confused.
Yes, can you ask your
It's
question?
as if four different things. I'm no more because I don't know, but the one that Mr. Jamjo showed us, he first of all differentiated. He was differentiated the y, the x of lambda. After he differentiated again, he differentiated two times, and now he has not even differentiated even one time. So I don't understand if it's the same thing that we're doing.
I have differentiated 2 times.
Where?
Let me go down to it and you see. Here is it now.
What you call what? What to call y prime is differentiation.
Yes, it's my differentiation now. Here, this is it here. I don't know if you're seeing.
Yes, I'm seeing.
Yes, so I'll let my yp to be something based on the right hand side. Then I'll differentiate it the first time, and I'll differentiate it the second time. Then I will place back into the differential equation and solve for the lambda.
Okay, I'm seeing. Yes, it's the same thing.
Okay. Okay. Now, let me take a situation where the particular integral will also depend on a complementary function. So let's say we have the squared y by the x squared plus 9 dy by the x plus 9y is equal to let me say dbe to the power negative 3x. Let me put 6 here. Yes. So let's look at this case. So 1, find a complementary function. Secondly, find a particular integral. And thirdly, find a general solution. Okay, so let's begin with a complementary function. So for the complementary function, we know that we solve the auxiliary equation m squared plus 6m plus 9 equal to 0. Now, the left hand side is just m plus 3 all squared. Yes, Grace, I'm listening.
Please,
Yes.
when finding the complementary equation, must the summation of d squared y dx squared be 1?
No, no, no. It must not be 1.
Okay.
It can be something else. It must not be 1. That's why in a general form, we just put A. Okay, so we have m squared plus 6m plus 9 equal to 0. So it means m plus 3 all squared is equal to 0. So here we are just going to have two roots that are equal, which is negative 3. So m equal to negative 3. So real and equal roots. So for real and equal roots, our complementary function is of the form a plus bx e raised to the power that root times x. So that's our complementary function. So where a and b are all real numbers. Okay, now the second thing to do is to find a particular integral. This is where trouble starts. Now, I'll check my right hand side. My right hand side is of the form 3e to the power negative 3x. So, my initial guess of my particular integral is actually lambda e to the power negative 3x. That is my initial form. But now, we in this case, this particular integral also depends on the complementary function. Why? Now, if I expand my complementary function normally, I'm going to have here a times e to the negative 3x plus bx e to the power negative 3x. That is what I'm going to have. So whenever I have the initial guess of my particular integral, I must now come back to the complementary function and verify if that initial guess can be found there. So in this case, the initial guess of the particular integral was lambda e to the power x. If we come back to the complementary function, we realize that we cannot find it there. It's impossible to find it there. So I'll normally going to proceed with that initial guess. But now, in a case where you go back to the complementary function and you still find it there, there is something you have to do. So my initial guess is lambda e to the minus 3x because that is what my right hand side is all about. I will now come back to the complementary function after expanding and check if I can find this exact form there. And if we check, this is the exact form here. A and lambda are constants, so this form is exactly the same as this form. So when this happens, what you do is that you now multiply your initial guess by an x. So let me write it down. When you find the exact form of your yp in yc, multiply yp by x until you can't find it there again. So the first time, the initial guess is this lambda e to the minus 3x. I'll come and check here. Can I find it? Yes, I can find it. This is it here. So I'll now multiply this man by an x. And I'll check again. Lambda x e to the minus 3x. Can I find it here? Yes, I can find it. This is the exact form here. Bx e to the power negative 3x. This form is exactly like that form. So I'll still multiply this second guess by an x again, so it now becomes x squared. And I check again if I can find it. This cannot be found here again. So this is going to be my final particular integral. I don't know if this concept is clear. Eunice.
Yes, sir, I'm listening.
Is it clear?
And yes, I'm getting it because yes, it is clear.
Okay. Blessing.
So Blessing face is not clear.
Yes, I need her question. Blessing, is there any particular worry?
Please, yes, please, what do you get x squared? Please, can you explain how you got it again?
Okay, again, when we have, look at the right hand side, 3e to the minus 3x. So what is going to be our initial guess of the of a particular integral? This is it, right? Lambda e to the minus 3x. Now, when we have this initial guess, we have to come back to the complementary function and check if this initial guess is found there. If it is not found there, we'll just proceed with the initial guess like that. But if it is found there, we have to now multiply the initial guess by an x. So you come and check, you realize that this lambda e to the minus 3x is exactly as a e to the minus 3x. They are of the same form. So what I'm going to do is that I will multiply this guy by an x. So normally this lambda x e to the minus 3x is now my new yp. When I do this, I will now have to go back again and still check again if I can find the new yp in the complementary function. And you realize that this form is exactly this form. So what I'll do is that I still multiply this man by an x again. That is why this now becomes x squared. Is it clear now?
Yes, sir. Thank you. I've understood.
Okay. So in this case, this is actually our yp. So we have to differentiate the first time, the second time, and we replace in the differential equation and find the value of lambda. So if we differentiate the first time, yp prime, let me just say dyp by dx is equal to, now I'll keep lambda because it's a constant. Then to differentiate this other man, I'll use product rule. If I keep x squared, I'll differentiate e to the minus 3x, which will give me minus 3 times e to the power minus 3. Yes, Eunice, I'm listening.
It's not only. Not only. No. It's not
Yes,
only.
oh, stop noise. Eunice, I'm listening. The phone is 2%.
Listen, since I can actually tell you something about it.
Go with it to the remote, or it is a folder. Can we proceed? Please, I don't know if you can proceed there.